Welcome my dear students. Previous day I talked about the PV indicator diagram and its work done calculation. Today we know the work done process for encyclic and cyclic process. Now what is encyclic process? When a system returns to its original position it is said to be cyclic process. When a system returns, or when a system means here cycle, when a cycle returns to its original position, it is said to be cyclic process, otherwise it is non-cyclic process. So what is cyclic process? I draw two diagram for non-cyclic and cyclic process. A and B, the coordinates here is P1 V1 and here P2 V2. If the process continues from A to B point, that is the pressure changes from P1 to P2 and V1 and volume changes from V1 to V2, then this process is called non-cyclic because it does not return to its original position, and work done is simply the PV indicator diagram and the volume axis area enclosed by PV diagram, that is the this curved line, and the and if we draw two perpendicular named C and D, then it is the area and the volume axis. If this is volume axis, then the area and the volume axis is the then the PV indicator diagram and the volume axis gives the total area, that is area of ABCD gives the work done for non-cyclic process. But if the process is cyclic, suppose the process starts from point A and via point X it goes to B and it returns through Y to initial point A, then what will be the work done? And this is obviously cyclic process. This process is cyclic process. So this is cyclic process, and the work done is calculated if we draw two perpendicular C and D. Then work done for this cycle, that is AXB cycle, is area of, here work done W is equal to the area, work done W is the work done for A to A cycle and B to A cycle, A to B cycle and B to A cycle. Now what is work done for A to B cycle? A to B cycle is work done for A to B cycle is area of AXBCD, this area is work done for WA to B. This is work done for WA to B, and WB to A is equal to area of BYA DC. Now the work done for work done for clockwise is positive. So the work done for A to B is positive, but the work done for B2 is taken as counterclockwise. This is negative. This work done is AXBCD is taken as counterclockwise, so it is positive, and the work done BYADC, it is taken as anticlockwise or counterclockwise, so it is negative. So the total work done is for cyclic process. Therefore, W total for cyclic process is WA to B minus WB to A. That is area of AXBCD minus area of BYADC, that is the area of this minus the area of this, that is the area of loop AXBYA, this loop AXBYA. So simply for cyclic process, the work done is nothing but the area of the closed loop. The area of the closed loop is work done for any cyclic process. Now we go with some example. The things will be more clear. Suppose this is a PV indicator diagram and this is a process PQRS. The process happens in anticlockwise direction. The value of P is 100 kilopascal and Q is 200 kilopascal. The volume of this point is 100 semi-cube and this S point volume is 300 semi-cube. Now find the work done for the cycle, for the loop PQRSP. As we take the loop in anticlockwise direction PQRSP, sorry, this is clockwise direction PQRSP, as this is taken in clockwise direction. So the work done is positive. So the total work done is given as the area of this loop, that is PS cross PQ. What is the value of PS? 300 minus 100 semi-cube into what is the value of PQ? 200 minus 100. 200 minus 100 kilopascal. That is 200 semi-cube into 100 kilopascal. That is 200 into 10 to the power minus 6 meter cube, centimeter cube transferred to meter cube by 10 to the power minus 6 multiplication into 100 into 10 to the power 3 Pascal. So the total work done is 200 into 100 into 10 to the power minus 3 joule.